Hi, my name is Austin Beam, and I'd like to take this opportunity to tell you a little bit about the project that we've done for TI's Design Challenge for Co-ops. We've decided to create an interactive periodic table based on an LED matrix. Now this is controlled at the input by a Capacitive Touch BoosterPack connected to a LaunchPad. It's also connected to our system in a BoosterPack type configuration. The Capacitive Touch events are interpreted by the LaunchPad and then passed via UART to the primary microcontroller of the system, which is here, the MSP430 F5310. Now the 5310 was chosen, among other things, for the fact that it has much higher available RAM than the Value Line series chips do. They all have 512 bytes of RAM, and this chip has 6K of RAM, which makes it a lot easier if you want to interface with peripherals, especially when you're talking about like a micro SD card. You can see on the back that we have a micro SD card slot, and that's where the data for the individual elements is stored, and that's where we can pull the data when we output it to the user. So to interface with an SD card, it was going to be really difficult to use a chip that only had 512 bytes of RAM because all of the sectors are 512 bytes. So bumping up to the 6K of RAM in the 5310 makes life a little bit easier for us. Also on the bottom here we have the programming header, which uses SPI-by-wire functionality of the LaunchPad. That was something we really wanted to showcase because it's really a fantastic functionality of the LaunchPad. It's really easy to use, and it kind of brings all of the MSP430 products to everyone at a very reasonable, very reasonable, excellent price point with the $4.30 LaunchPad. So you have the SPI-by-wire header, and it has the two pins for programming. It also has the RX, TX pins, which are used for UART, and just power and ground here. Then you also have an LCD header. Now we used the LCD in prototyping and it worked fine, but in this configuration we felt it was better to use the UART output. You get obviously a lot bigger display. You can put a lot more information on there, which is a lot more user-friendly. Nobody wants to have to scroll through lines and lines of data out of files on a little bitty LCD, so that's kind of why we chose to go with UART. You can see the LaunchPad is plugged into USB. That's the 5 volt connection is actually isolated here, but the 3.6 volt connection is tied to the LaunchPad. So we have 3.6 volts coming out of the LaunchPad, powering the microcontroller and also the SD card and everything that runs in the system at that voltage level. You can see on the top, of course, we have our microcontroller, the F5310. We have two transistor arrays. These are the ULN 2003s. They're used in conjunction with the decade counter to control the rows. So the decade counter is sent a clock pulse, and that allows us to iterate through the rows one at a time. And this allows us to create an effective scanning mechanism alongside the shift registers, which are on the back. These are SN74HC595N shift registers. Now these are all TI products. They can all be had for free through the sample program. All the active components, the shift registers, the decade counter, and the transistor arrays. So that's one great functionality of this. This is something that you can put together on a breadboard, the circuitry, if you want to play with just an LED matrix, like a basic one. And that's pretty cool. Something that you can have a lot of fun with. So I think that kind of outlines what we've got on the board. Now maybe we'll talk a little bit about functionality. So, I said that the events were interpreted by the capacitive touch sensor. Now, what we did was we created the sense of we want to be able to interpret both gestures and directions. So that's what we did. Because the demo code sends out both these different types of events, it was basically just a matter of implementing the hardware UART on the 5310 and then interpreting those commands. So for example, if you get a clockwise gesture, then we increment each element. So we go from 1 to 2 to 3 to 4 to 5 and so on and so forth. So that makes it make logical sense. If you're going clockwise, you're going to increment elements, and if you're going counterclockwise, you're going to decrement elements. Now, on the flip side, when you're using directional control, the up and down, left and right, that's literally going to go up, down, left, and right in the periodic table. And that makes for a more dynamic control system. It makes it a little bit easier to get around. You might not necessarily want to go, if you wanted to go to 118 from 1, you might not want to go all the way scrolling. That get kind of annoying. So that's why we kind of isolated those functionalities and create the ability to maneuver through the table. Alright, so let's talk a little bit about how the system works to kind of demonstrate some functionality. So we're going to go ahead and reset the system with the reset button. You should see the atomic number 1. So We're over here at hydrogens. That's so letting us know on the output of the display. And that's what it's going to tell us every time we increment or decrement an element. It's just going to give us the atomic number so we know where we are on the table. Same as looking at the table on the console. This could eventually be interpreted by some type of GUI and you know, kind of tied together to make this a really integrated solution. So I'm going to go ahead and wake up the Capacitive Touch BoosterPack. As we said, this is the demo code. And so you see that it works exactly the same as anyone who's tried it before has used it. That's exactly how it works. So we're going to wake it up. And then I'm going to go over to helium. So it's going to tell me, all right, I'm at atomic number 2. Now I want to see some details on helium. So I'm going to push the middle button. And it goes out to the SD card. And it pulls all the data that we have on helium. Now, in this particular case, it's kind of difficult to see everything because I have the font set really large. But typically on a serial console, you're able to see everything about that element all right there in one nice little chunk for you. So, alright, I got my info on helium, but I want to go down, check something out over on this part of the periodic table. So it's going to pull that data as well. So you can see how that works, and then I can go through the other elements and tell me where I am. So right now I'm on 113. I want the data on 113, so press the middle button, and it tells me, so 113 is ununtrium, that's atomic number 13. You can see the symbol, etc. We go through, on some of these, there's not a whole lot of detailed information when you get to the newest elements. So we just found as much information as we could and put it on there. Now one cool thing about this is because all this data is stored on the SD card, any user of the system can simply take the SD card out, put it in the computer, and change the data for any of the elements. And so that's exactly what it will print out when you get there. It's kind of like an advanced flashcard system that you can use with elements. This is kind of handy. It's kind of cool. So if you have any questions or anything, just shoot them over to us in the comments. Suggestions, anything for improvements, that we'd be glad to hear them. Like I said, this is definitely something that we would potentially integrate with a graphical user interface at some point, and that would make it much more powerful. But for right now, you see the serial output on the computer. We do have this LCD header in place, so that could also make it a more portable solution. But obviously we're relying on 5 volts from the wall as it is to power the system, so you're not completely mobile. This could obviously be adapted to something like that as well. So it's a nice little tool. It's a great learning experience for us. It was really neat to see the functionality of the LaunchPad in the form of SPI-by-wire. That is an excellent solution that really brings MSP430 to the masses. $4.30, you're getting a great little device in the LaunchPad that can do a lot of things, including program all the other MSPs that support SPI-by-wire. So that's our project, and thanks for watching. Appreciate your time. Have a good day.